file upload vulnerabilities. What are file upload vulnerabilities? Let's discuss it in detail. So file upload vulnerabilities occur when a web server lets users upload files to its file system without properly checking items like their name, type, contents, or size. Uploaded files present a significant risk to apps. The first step in many attacks is to get some code into the system under attack. The attacker simply needs to find a way to execute the code. Using a file upload enables the attacker to complete the first stage. The implications of unrestricted file upload can range from complete system takeover to an overload file system or database, forwarding attacks to backend systems, client-side attacks, or simply defacement. It depends on what the application does with the submitted file and where it is stored. There are two types of problems here. The first issue is with the file metadata such as the location and file name. HTTP multi-part encoding, for example, is often provided by the transport. This data may lead to the application overwriting a critical file or storing it in an incorrect location. Before using the metadata, it must be thoroughly validated. The third type of issue is one of file size or content. The range of issues here is entirely dependent on what file is used for. To defend against the attack, analyze everything your application does with files and consider what processing and interpreters are involved. Moving on to our next step, that is prevention from file upload vulnerabilities. Let's discuss. Only allow specific file types. One can prevent executable scripts and other potentially harmful content from submitting to our application by restricting the list of acceptable file types. Verify file types. It is essential to ensure that no files are masking as acceptable and restricting the file types. For example, if an attacker renames an exe to docs and your solution is entirely based on the file extension, it will circumvent your check as an Word document, which it is not. As a result, it is critical to validate file types before allowing them to be uploaded. Scan for malware. All files should be malware scanned to reduce risk. To get the maximum detection rate and the shortest exposure window to malware outbreaks, we advocate multi-scanning files with various anti-malware engines, using a combination of signatures, heuristics, and machine learning detection approaches. Remove possible embedded threats. Files such as Microsoft Office, PDF, and picture files might include hidden threats in hidden scripts and expressions that anti-malware engines do not always identify. To eliminate danger and ensure that files do not contain any hidden threats, it is recommended to remove any possible embedded objects using a technique known as content disarm and reconstructor. Authenticate users. It is the best practice to ask users to authenticate themselves before uploading a file to boost security. However, this does not guarantee that the user system was not infiltrated. Set up maximum name length and maximum file size. To avoid a potential service disruption, define a full name length, restrict allowable characters if visible, and file size. Randomize upload file names. Alter the uploaded file names randomly so that attackers cannot access the file with the file name they uploaded. When implementing deep CDR, the sanitized file can be configured as a random identifier, example the analyst data _ID. Store upload files outside the web root folder. The directory to which files are posted should be outside the website's public directory so that attackers cannot execute the file via the supplied path URL. Check for vulnerabilities in files before uploading software and firmware files. Ensure that they are free of vulnerabilities. Use simple error messages. Include no directory location, server configuration data, or other information that attackers could potentially exploit to gain further access to your systems when showing the upload problems. File upload is a vulnerability that allows an attacker to upload malicious files to the server when a web application doesn't have proper validation and security checks in place. For this practical, we are going to use DVWA. DVWA is a free and open source web application with well-known security vulnerabilities. Log in into the web application using the credentials admin as username and password. Click on the upload web page. The web application starts at low security level by default. Low security level. Click on upload and you can see that the web application allows the user to upload an image. Click on browse and select an image and click on upload. As you can see that the web application has uploaded our image to a location which is 2 directories back. Let us view the uploaded image. Now we can try to exploit the functionality by uploading a PHP reverse shell and gain shell access to the server. For this, we are going to use a PHP reverse shell from Pentest Monkey website. Search for PHP reverse shell and navigate to the GitHub repository and copy the PHP reverse shell and paste it in a file in Kali using the command nano shell php. Run the ifconfig command to get the IP address of our Kali machine. Now modify its IP address in the PHP reverse shell with our Kali IP address. We need to start listening for the incoming reverse shell as well. This can be done using netcat. Type the command nc-nvlp1234. Now click on browse and select our shell PHP and click on upload. As you can see, we have successfully uploaded a PHP reverse shell. Now execute the reverse shell and you can see that we have received an incoming request giving us shell access to the server. Medium security level. Click on DVWS security and select medium from the drop down and click on submit. Click on browser and select the shell PHP and click on upload. As you can see, we can get the error that the image was not uploaded in Kali. Change the name of shell.php to shell.php.jpeg. Click on browse and select the shell.php.jpeg and click on upload. As you can see, we have successfully uploaded the file. Now start burp suite and turn on intercept and turn on burp in Foxy proxy. In burp, change shell.php.jpg to shell1.php and forward the request. Turn off the intercept and burp from Foxy proxy. Start a network listener using the command nc-nvlp1234 and navigate to the uploaded file location. As you can see, we have received an incoming request giving us shell access to the server. High security level. Click on DVWS security and select high from the drop down menu and click on submit. Start burp suite and turn on burp suite and turn on burp in burp Foxy proxy. Click on browser and select the shell.php.jpg and click on upload. In burp, change shell.php.jpg to shell.php and forward the request. As you can see, you can no longer upload a malicious file to the server.